Section 6.3, trig equations 2. So the first equation we're going to talk about is this one here. Cosine of 2x equals 1/2. So the way to look at this is to think about this in terms of like getting to that 2x here on the inside. And the way we're going to do that is the idea is just this cosine inverse function. So cosine inverse of the cosine of 2x equals the cosine inverse of 1/2. So if we think about what that is in terms of the unit circle, so let's just kind of draw that out here. If I'm going to look at the cosine inverse of 1/2 here, I'm going to have to draw this triangle, and it's going to be in the first quadrant because cosine inverse is either in the first or second quadrant. And since it's positive, it makes it in the first. And cosine is adjacent over hypotenuse. So it's going to be 1, and then a 2 is going to be the hypotenuse. Okay, so this means that the other side here, if I did the Pythagorean theorem, that this would be square root of 3. And this is our special triangle. I know right away this angle here is also 60 degrees. So how that helps us here is when I do this cosine inverse of cosine, oops, that cancels out here, oops, that cancels out there, and I end up with a 2x on the left side. And then on the right side, I actually get the 60 degrees. Now to get the rest of this, what I'm going to do is divide by 2. Divide by 2. So x actually equals 30 degrees. So that is my first answer for this problem. So to get the rest of the answers for this, I can't use the inverse function because the inverse is 1-to-1, so that means I can only get the one answer. So I have to think about this idea of analysis. And I think about the idea of where else is cosine of 2x equaling 1/2. Where is it going to be a positive 1/2 at? And I would say the fourth quadrant, so I would draw that down here. And I know that this is going to be the square root of 3. I know this is going to be 2, and I know this is going to be the 1 right here. So it's going to be the same for this one, and I know this angle here is going to be 300 degrees. So then again, not only is this 2x going to equal 60 degrees, but that 2x is also going to equal 300 degrees. And then when I divide that by 2 and divide that by 2, x is going to equal 150 degrees. Now that's 2 of our answers, and there's actually more than that because this tells me to find all the answers from 0 to 360. So let's find the other ones now. Okay, so that's only 2 answers. So what we can do is, in general, if we had 60 degrees, remember when we did this a while ago, or in the last video, where I had 60 degrees plus 2, not 2 pi, I was going to write 2 pi n, but 360 n. Okay, so what I'm going to do is I'm just going to add another 360 here to this 60 degrees. I'm going to do n equals 1. So that's going to give me 360, 420 degrees. So now I'm going to say 2x equals 420 degrees. And then when I divide that by 2 and divide that by 2, my x is going to actually equal 210 degrees. So there's my another angle that's actually between 0 and 360. I'm going to do the same thing for this second one here. So I'm going to take that 300 degrees and add 360 degrees, and that's going to be 660 degrees. And when I take that 2x equals 660 degrees, and I divide it by 2 and I divide it by 2, my x is going to actually equal 330 degrees. Now, if I had tried this again, let's say I did the same thing with this one, and then now I'm going to, with this one here, and then I'm going to try to add 720 to it, you'll realize that I would actually be over 360 degrees. So the four answers for this are going to be here, 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 and here. And those are all of them. One way I think of this is anytime I'm dealing with cosine of 2x, I do realize I get two cosine curves from 0 to 2 pi. And I do realize that this is 1/2 here, and if I took it all the way across, how many answers would I get? I get 1, 2, 3, 4. So I'd actually get 4 answers. So that kind of helps me to determine how many answers I should get too when I'm between 0 and 360. So let's try another problem. All right, so let's take sine of theta over 2 equals negative square root of 2 over 2. Now think about what this means here when I have the sine of theta over 2. That simply means I get half a sine curve from 0 to 2 pi. And these are the ideas I actually think about when I'm dealing with this. And let's say this one is going from 0 to 2 pi. So then that means I would just get this upper part, wouldn't I? And then if I'm at negative root 2 over 2, how many answers should I get? We'll have to take a look at what that means here. So the first thing I'm going to do is I think of that idea of sine inverse of both sides. So I'm going to get a theta over 2 equals, and I have to figure out what that root 2 over 2 looks like here. So I'm going to draw my unit circle idea here. And then what I'm going to do now is I'm going to think about the sine inverse. What quadrant is that going to put me in for negatives ratio for sine? So it's going to put me down here. And then I know this is really 1 here, and then square root of 2, because I know root 2 over 2 is really 1 over root 2. It's the same thing. So there's a 1 there. And I know here that that's 45 degrees, but since we're talking about radians, that it's pi fourths. Okay, so it's sitting there. So now when I actually look at where this is at here, I can go, okay, so that angle then, to go all the way around, remember if it went all the way around, it would be 2 pi or 8 pi fourths. And that's one left, so that angle is going to be 7 pi fourths. So if you look at this, that's telling me then that this is 7 pi fourths here. And then what would I have to do to solve for theta? I would have to multiply both sides by 2. So theta would actually equal 7 pi halves. Now if you look at 7 pi halves, that's way over 2 pi. So this tells me I would actually have no solution if I was going from 0 to 2 pi. Because think of this. If I was just adding all those angles up, this would be half pi. That'd be 1/2 pi, 2 halves pi, 3 halves pi, 4 halves pi, 5 halves pi, 6 halves pi, 7 halves pi. So I went all the way over here in order to get my first theta here. So that tells me right away that I'm going to have no solution from 0 to 2 pi. Because I had to continue longer and further down for that to happen. And that would actually be down here somewhere. That's where my answers would be. And it would actually be 7 pi halves where I'd get my first one.